Let's discuss the properties of fundamental particles. Proton has a charge of plus 1.6022 into 10 raised to power minus 19 coulomb. It has a relative charge, that is absolute charge, plus 1. The mass of proton is 1.6727 into 10 raised to power minus 27 kilogram, and the mass in AMU, atomic mass unit, is 1.0073, and it is present in the nucleus. Neutron has no charge. Its relative charge is also 0. The mass of neutron is 1.6750 into 10 raised to power minus 27. Its mass is 1.0087 atomic mass unit, and it is present in the nucleus. Electron has a charge minus 1.6022 into 10 raised to power minus 19 coulomb. Its relative charge is minus 1. Its mass is 9.1095 into 10 raised to power minus 4. Its mass is 5.4858 into 10 raised to power minus 4 AMU, and it is present outside the nucleus. 1 AMU is equal to 1.6 into 10 raised to power minus 27 kilogram. You have to remember this table and this conversion. It can come in the MCQs. Yes, students, let's discuss Bohr's atomic model. It's a very important model. In order to remove the defects of Rutherford atomic model, Bohr presented his atomic model. According to his model, the electrons revolve around the nucleus in definite energy levels called orbits or shells. These are the shells or the orbits or the energy levels, and they are definite, means they have definite amount of energy. Point number 2, as long as electrons remain in a shell, it never gain or loses energy. As long as the electrons revolve in the same shell, it neither loses energy nor it gains energy. Point number 3, the electron, when jumps from the lower energy level to the higher energy level, it absorbs energy, and when electron jumps from the higher to the lower energy level, it radiates energy. Point number 4, angular momentum, that is the rotation, that is mvr of an electron. M is the mass of an electron, v is the velocity of an electron, and r is the radius of an orbit. This is the radius of first orbit, this is the radius of second orbit, and this is the radius of third orbit. So the angular momentum mvr of an electron is equal to nh over 2 pi, where n is the quantum number, or we can say that n is the shell number. For shell number 1, n value is equal to 1. For the second shell, quantum number or n value is 2. For the third shell, n value is 3. And angular momentum depends upon the quantum number, that is n value. And the factor h over 2 pi is a constant factor, where h is the Planck's constant, and this factor, when multiplied by an integer, n is an integer, it can be 1, it can be 2, it can be 3, or any other value. So when this constant factor, that is h over 2 pi, is multiplied by an integer, we get angular momentum mvr. So the angular momentum of an orbit depends upon its quantum number. As the quantum number change, the angular momentum also change, and angular momentum is an integral multiple of the factor h over 2 pi. It means when we multiply an integer, that is n, with this constant factor, we get angular momentum mvr. Students, let's discuss this topic. 2.2.1, it is derivation of radius of an orbit of an atom. It's a very important topic. It comes as a long question. So let's discuss this topic. First of all, let's discuss a diagram. In this diagram, electron is revolving around a nucleus. Electron has a charge E minus and nucleus has a charge Ze plus, where Z is the number of protons. The mass of electron is m, and electron has a velocity that is equal to v, and the radius of the orbit is equal to r. Bohr derived an expression for the calculation of radius of nth orbit of hydrogen atom, or ions like He plus 1 Li plus 2. Bohr derived an expression. This expression is used to calculate the radius of nth orbit of hydrogen atom, helium and lithium ion. We can calculate by using this expression. We can calculate the radius of any orbit of hydrogen atom or helium or lithium ion. We know that, students, hydrogen atom contains one electron. How this helium ion is formed? When helium containing two electrons loses one of its electron, it is converted into a positively charged Hi+1 ion, and this helium ion contains one electron. Lithium atom contains 3 electrons, and when lithium loses its 2 electrons, it is converted into Li+2 ion, and this lithium ion contains 1 electron. So, hydrogen atom He+1 and Li+2 contains only 1 electron. We can say that these are monoelectronic systems. So, by using Bohr expression, we can calculate the radius of monoelectronic systems only. Yes, friends, so let's discuss this diagram again. The electron experiences a force in the inward direction towards nucleus, and this force is known as the Coulomb's force of attraction or electrostatic force of attraction between opposite charges, that is negatively charged electron and positively charged proton. So according to Coulomb's law, the electrostatic force or Coulomb's force of attraction is equal to Ze plus multiplied by E minus over 4 pi epsilon naught r square, or we can say that the Coulomb's force of attraction is equal to Ze square over 4 pi epsilon naught r square, where Z is the atomic number, E square is the charge, that is positive and negative, then 4 pi epsilon naught. What is epsilon naught? Epsilon naught is the vacuum permittivity constant. It is a constant and it has a value 8.84 into 10 to the power minus 12 coulomb square per joule per meter. So, students, we have discussed about the electrostatic force of attraction which is acting in the inward direction. Centrifugal force is also acting on the electron in the outward direction, and this centrifugal force on the moving electron is equal to mv square over r. Both these forces are equal and opposite and they balance each other. So we can say that the centrifugal force is equal to the Coulomb's force of attraction. mv square over r is equal to Ze square over 4 pi epsilon naught r square. We will cancel r and we will get the equation mv square is equal to Ze square 4 pi epsilon naught r. On rearranging, we will get the equation r is equal to Ze square 4 pi epsilon naught mv square. So what we have done, mv square, which was multiplied on the left hand side, when this mv square is written on the right hand side, it is divided, and r, which is divided on the right hand side, when we bring r on the left hand side, it is multiplied. So in this equation, that is equation number 2, we can see that r is inversely proportional to the square of velocity. It means as the value of r increases, as the value of radius increases, the velocity of electron decreases. The electron, which is nearer to the nucleus, moves with a greater velocity because the value of r is small, and the electron, which is far away from the nucleus, moves with less velocity because the value of r is greater. So we can conclude that the radius of a moving electron is inversely proportional to the square of its velocity. When the value of r is small, then the electron moves with a greater velocity. When the value of r is large, then the electron moves with less velocity. Yes, friends. Now we know that the value of angular momentum according to Bohr is equal to mvr is equal to nh over 2 pi. On rearranging, we will get this equation: v is equal to nh over 2 pi mr. M and r are multiplied on the left hand side. When we will write mr on the right hand side, they will be divided. Now we will take the square of this equation on both sides and we will get equation number 4, and that is v square is equal to n square h square. 2 the whole square is equal to 4, so 4 pi square m square r square. Now what we will do, this is equation number 2. Equation number 2 is r is equal to ze square over 4 pi epsilon naught v square. We will insert the value of v square in equation number 2. But in equation number 2, v is written in the denominator. So when we will insert this value of v square in equation number 2, then we will invert this equation. We will invert the equation of v square and then we will put the value of v square in equation number 2. So the equation will become r is equal to ze square 4 pi epsilon naught m, and now we will insert the value of v square and the factors that are written in the numerator, now they will be written in the denominator, and the factors that are written in the denominator, they will be written in the numerator. So for r is equal to ze square 4 pi epsilon naught m, 4 pi square m square r square over n square h square. We will cancel the same factors, that is 4 and 4 will be cancelled. 4 and 4. 1 pi and 1 pi will be cancelled. 1 m and 1 m will be cancelled. So we will get the equation, this r and 1 r will be cancelled from here. So we will get the equation 1 over 1, nothing is over here, so we have written 1 over 1 is equal to ze square pi m r over epsilon naught n square h square. Yes students, next we will cross multiply. So on cross multiplying, the factors that are given in the numerator will be written on the left hand side and the factors that are given in the denominator will be written on the right hand side. We are cross multiplying the factors that are given in the numerator with 1 and we are writing on the left hand side, and the factors that are written in the denominator we are cross multiplying it with this one and we are writing on the right hand side. So we will get the value of r, we will rearrange this equation and we will get the value of r. All these factors are multiplied when they are on the left hand side. When we will write these factors on the right hand side, then they will be written in the denominator, they will be divided. So the value of r is equal to epsilon naught n square h square over ze square pi m. Yes students, so this is our equation number 5 that we have derived. Now for hydrogen atom, let's derive the radius for hydrogen atom. For hydrogen atom, the value of z is 1. The value of atomic number is 1. So we will put the value of z, that is equal to 1, in this equation and we will get the equation r is equal to epsilon naught n square h square over z. Z is equal to 1, so we will not write that value. over E square pi m. Now, students, we notice that R is directly proportional to n square. As the value of n increases, the value of R also increases. As the value of n increases, the value of, this is a nucleus, as the value of n increases, the value of R also increase. And this is a constant factor. E naught, it is a constant value. Planck's, it is H is Planck's constant. E is the charge. Pi, m, all these are constant. So we will get an equation R is equal to n square multiplied by A naught. What is A naught? A naught is equal to this constant factor. That is, A naught is equal to epsilon naught h square over E square pi m. And when we will insert the value of all these constants, we will get a constant quantity, that is A naught, having a value of 0.529 into 10 raised to the power minus 30 meter, or we can say that 0.529 into 10 raised to the power minus 30 meter is equal to 0.529 angstrom, as 1 angstrom is 10 raised to the power minus 30 meter. So instead of writing 10 raised to the power minus 30 meter, we write 1 angstrom. Angstrom is also the unit of length, as meter is a unit of length. So we will get the value of R. We will put the value of A naught, that is 0.529 angstrom, in this equation, and we will get the value of radius as R is equal to n square into 0.529 angstrom. So students, let's calculate the radius of first orbit of hydrogen atom. That is, the value of n for the first orbit is 1. So R is equal to 0.529 into, we will insert the value of n for the first shell, and that is equal to 1. So 1 square, and we will get the value 0.529 angstrom. Let's calculate the radius for the second orbit. For the second shell, n value is 2. So R is equal to 0.529 into 2 square, because n value is 2. So we will write 2 square, and the value will be 2.116 angstrom. For the third shell, n is equal to 3, and the value of R will be 0.529 into 3 square, because the value of n is 3, and we have to take the square of n value, and we will get the answer 0.475 angstrom. This is the radius of the third orbit. And for the fourth orbit, the value of R is 0.529 into 4 square, that is 8.4 angstrom. Yes students, your assignment is question number 2 part 6. Which species are formed by the decay of neutron? We have discussed in the properties of neutron. Question number 2 part 14. You have to answer the questions by looking at the diagram. Question number 3. You have to derive an expression for the nth orbit of hydrogen atom. Thank you students, and